Right now, further away from Earth than any human-made object in history, a small metal spacecraft the size of a compact car is drifting through complete darkness, alone at over 38,000 miles an hour. It launched in 1977. Its power source is slowly dying, and it is still, right now, sending a signal back home. A whisper so faint it takes over 23 hours just to reach us. This is Voyager 1, and its story is one of the strangest and most quietly emotional in the history of space exploration. It was never designed to be humanity's most isolated object. It was built to do a 5-year tour of Jupiter and Saturn. Everything that happened after that was, in a very real sense, a bonus round nobody expected to still be running nearly 50 years later. Let's start with where it actually is. Voyager 1 is currently more than 15 billion miles from Earth. So far that it has already left the heliosphere, the protective bubble of charged particles our sun blows out into space. In 2012, it became the first human-made object to enter interstellar space, the region between star systems, filled with material left over from other stars that died long before our sun was born. To put that distance into perspective, light itself, the fastest thing in the universe, takes over 23 hours to travel from Voyager 1 back to Earth. When our engineers send it a command, they wait nearly 2 full days for a reply. Every single interaction with this spacecraft happens across a gap of time that makes ordinary communication feel almost meaningless. Here's where the story gets stranger. Voyager 1's radio transmitter broadcasts at about the same power as a refrigerator light bulb. Yet NASA's Deep Space Network, a set of enormous radio dishes scattered around the globe, can still detect that signal, buried in a wall of cosmic noise from over 15 billion miles away. Engineers have described it as trying to hear a whisper from the other side of the planet during a hurricane. The spacecraft is powered by something called a radioisotope thermoelectric generator, which converts the heat from decaying plutonium into electricity. It doesn't need sunlight, which is good, because at this distance, the sun is just another faint star in the sky. But that power source loses about 4 watts every year, permanently, with no way to refuel it. Engineers have had to shut down instrument after instrument over the decades just to keep the spacecraft's most essential systems and its ability to phone home alive. A hurricane. In 2023, something happened that terrified the small team still monitoring Voyager 1. The spacecraft suddenly began transmitting what looked like complete gibberish, a repeating, meaningless pattern instead of real data. For months, nobody knew if this was the end. Engineers who had worked on the mission since their 20s, now in their 60s and 70s, dug through decades-old documentation, some of it stored on outdated formats, barely readable anymore, trying to diagnose a problem in a computer chip flying billions of miles away that they could never physically touch or replace. They eventually found it, a single corrupted memory chip, likely damaged by a cosmic ray strike after decades of exposure to deep space radiation. The fix required rewriting the spacecraft's code to root around the dead chip entirely, sending updated instructions across that same 23-hour gap, with no way to know if it had worked until nearly 2 days later. It worked. Voyager 1 spoke clearly again, for the first time in nearly 5 months, after both a human team and a decades-old machine nearly 40 light hours away quietly refused to give up on each other. Voyager 1 wasn't alone on its journey either. Its twin, Voyager 2, launched just weeks earlier on a different trajectory and became the only spacecraft in history to fly past all 4 of the outer planets: Jupiter, Saturn, Uranus, and Neptune. In 2018, Voyager 2 also crossed into interstellar space, becoming the second human-made object to leave the sun's protective bubble, following its sibling, by about 6 years. The two spacecraft are now moving in almost opposite directions, carrying nearly identical messages into two completely different patches of the galaxy. On board, both Voyager probes carry something remarkable: the Golden Record, a phonograph disc containing sounds and images meant to represent human civilization to any intelligence that might one day find it. Greetings in 55 languages, whale songs, Beethoven, a recording of a human heartbeat. It was assembled by a team led by astronomer Carl Sagan on the theory that the odds of it ever being found were astronomically small, but not quite zero. Before its cameras were shut down to save power, Voyager 1 did one more thing that wasn't part of any official mission requirement. At the request of Carl Sagan, in 1990, engineers turned the spacecraft's camera around, back toward the inner solar system it had just left, and took one final photograph. In that image, Earth appears as a single pixel, a barely visible speck of light suspended in a sunbeam from a distance of about 4 billion miles. Sagan later called it the pale blue dot, and pointed out that every person who has ever lived, every war, every triumph and tragedy in human history, happened on that one tiny, fragile pixel. Here's the twist that connects Voyager 1 to something happening in physics labs today. As it exits our solar system, Voyager 1's instruments have been quietly gathering data on something scientists still don't fully understand, called the heliopause, the exact boundary where the sun's influence ends and true interstellar space begins. The data it's sending back doesn't perfectly match our models. The boundary is messier, more turbulent, and stranger than physicists predicted, and Voyager 1 remains the only object we've ever built that's actually crossed it and reported back. NASA estimates Voyager 1 will lose its ability to power any scientific instruments by around 2025, and will likely go completely silent sometime in the 2030s, once its power drops below the threshold needed to transmit at all. At that point, it won't stop moving. It will simply keep drifting, silently, forever, carrying the Golden Record with it, on a trajectory that will take roughly 40,000 years before it passes anywhere near another star system. That's the part of this story that quietly gets people, once they really sit with it. Right now, humanity's furthest reach into the universe isn't a person, or a colony, or a telescope. It's a piece of 1970s engineering, still faithfully doing its job, alone, in the dark, long after almost everyone who built it has retired or passed away, carrying a message meant for someone we've never met, and may never exist. In the next video, we're looking at a single radio signal captured in 1977, the same year Voyager launched, that looked exactly like it could have come from an intelligent source, and that nobody has ever been able to fully explain since. Subscribe, because that mystery is still technically unsolved.